The milling process is important to ensure consistent, high-quality pulse flour is supplied to the industry so that they can maintain a consistent ingredient in their desired end product. Each pulse type has its own characteristics that can influence the milling process and the resulting flour quality. Seed size, shape, and hardness can all influence the milling characteristics. The composition of this pulse seed can also impact the way it mills. The fat content is particularly important because it can influence the way that the flour flows through the mill. Fat can cause stickiness in the flour, which can cause flow issues and screen blinding. Other properties of the seed, like protein content, can also influence the resulting flour quality. For example, higher protein content pulse flours, like a navy bean flour, can have higher water hydration properties. Each pulse type also has its own color, which will influence the color of the flour and the color of the end product that that flour is used in. All of these attributes can also be influenced by the variety of pulse type used and the growing environment that it's grown in. Milling technology plays an important role in the pulse flour applications because it influences the pulse flour's quality. Attributes like the composition, starch damage, water hydration capacity, and starch pacing properties can all be influenced by the milling type used. The starch damage content can influence how much water that flour absorbs, and the protein content and particle size are particularly important as they can influence the water absorption capacities as well. One of the most important parameters to consider when milling is the desired particle size of the end product. It is important to have a uniform and consistent particle-sized flour, as this will affect the water hydration properties when used in an end product. For example, when you have a wider range of particle sizes used in pasta, the flour will hydrate at different rates, affecting the end product's quality.
There are many different ways that are done to minimize variations in the finished product. It is important that the seeds are dehulled efficiently. The finished product wouldn't have some hulls that are adhering to the product. It is important to keep the settings consistent because changing the throughput or changing the speed of the rotor while grinding will impact the particle size of the finished product. It is important to know the moisture content of the seeds to be able to determine the amount of water added to reach that target moisture of 12% to 14%. There are many different types of milling machines that are used to process pulse seeds, and these can be categorized into two. The first one is what we call the single pass machines. And one of the examples would be the hammer mill, which uses hammers and beaters in a grinding zone, which is surrounded by a screen. The screen opening will determine the particle size of the finished product. The limitations in using some of the hammer mills is that it is not able to grind pulse seeds into very fine particle size. The other type of milling machine is what we call the Furker mill. It is similar to a hammer mill. The only difference is that the knives are installed vertically instead of horizontally. Again, this is surrounded by a screen. The type of screen that is installed will also determine the particle size of the finished product. The advantage of Furker mill over hammer mill is that it is able to produce very fine particle size as low as 140 microns. The other type of milling machine is what we call the pin mill, and this can even grind flour into very fine particle size. It's even finer than the flour that was produced from Furker mill. And usually pin mill is used to prepare flour for air classification because air classification requires a very fine particle size of flour. The other category is what we call the roller milling system, and this is very similar to flour milling, except that the flow diagram is not as long, and this involves a series of gradual grinding and sieving to produce different streams of pulse flour. The advantage of using a roller milling system is that processors can select different streams which has different properties, such as different starch damage or different protein content. There are different settings that can be changed throughout the process that will impact the properties of the final product. For the single pass machines, we can change the throughput or the feed rate. We can also change the RPM of the rotor inside the grinding zone. So the higher the RPM, the finer particle size of the product. We can also change the screen that we install. So different screen size will influence the particle size of the finished product. For roller milling system, we can change the grinding pressure or the roll gaps between the rolls. And we can also change the sieves to influence the particle size of the finished product.